And we'll start from current slide. Yes, we'll start from current slide. It's not doing anything, so let's do it again. Yesterday, in my early class, PowerPoint just went sort of bonkers and wouldn't do anything. I had to reboot everything. And now, okay, it's come back. All right, let me go over just a few, and again, these are office hours adjustments because of my doctor's appointment yesterday. They're not major, but they're little aggravating things perhaps, just to let you know. Because I missed 45 minutes of my first class yesterday, the class and I decided to make that up. There's Drew here, Lexi's here, Seth's here, and Emmett's here. All right. Anyone else come in since the call roll? All right. Now, since I missed 45 minutes because of my 112 class yesterday, what we did, we started 15 minutes early. So I made up 15 minutes of those. We still got 30 minutes left. So tomorrow, rather than being in my office from 8 to 8:15, I'm usually there before 8, 8 to 8:30, I'm only going to be there 8 to 8:15 because we're going to start 15 minutes early again tomorrow. We'll do the same thing on Thursday, which means, not be in the office at 8:15 like I normally am. I will be in class at 8:15. Those are minor. Okay. I also missed the entire trig class. Okay. And they and I decided to make that up on Friday. That's the day after tomorrow. So rather than being on the Birmingham campus, okay, from 8 to 12, I'm going to be here teaching trig at least from 9 to 10:15. Now, if I have to go back to Birmingham either before or after I teach the trig class, I will. But if I can get by with just being here, I'm just going to be here on Friday, not on the Birmingham campus. Okay. And I think that's the only adjustments I have. Except now this is not a temporary adjustment, this is permanent. Because I have a new second mini-term physical science class, and the first mini-term it started at 1:15, this one starts at 3:15. So what that means for us is my office hours on Tuesday, Thursday used to be 11:15 to 1:15, now they're 11:15 to 3:15. So I have more office hours on Tuesday and Thursday. Of course, that also means I'm here until 7:45 on Tuesday and Thursday, but that's fine as long as I have more office hours, right? All right. Any questions on anything we've done so far? Nobody else has come in since I called roll, so let's get going on where we left off last time. And I noticed something about the slides here. No, that's right. We were focused on simplifying a complicated fraction, in Module 12, page 14 on Module 12. And by the way, is anyone here who was not here Monday to pick up your quiz? All of you have your quiz. Okay, you don't. Okay. You. What's that?
After doing the quiz,
yeah.
I'm struggling with one major thing.
Okay. Well.
So can we do a different kind of problem? So
yeah, find one in the book that's similar to it.
Okay.
Okay, and I'll do that, and I can do it right now. I mean, if you can find it. Okay. Yeah. Whenever you can get it, yeah, we can do that.
Okay.
Yeah. So find it anytime you want to. Okay. So we are on page 14 of Module 12, and by the way, I did announce it last time, I believe. The instructors have been using this book, at least all the full-time instructors except one, and we haven't heard from him yet, but all the others really do not like this book. So we're going to go to a different book in the spring, but that will be for Math 098. The students in 098 now will keep their books and use that book for 100. Or if they have, well, let's see, yeah. If they have to repeat it, then that's their poor things. I mean, because they got to go to a new book. But so the Math 100 students for the spring will still be using this book, but after spring, nobody will be using this book. Will be in the new edition. Okay, a new book. All right. So we did the A part on focus on simplifying a complex fraction or complicated fraction. Let's go to the B part. And here it is written for us. Well, it's not quite written for us. Okay, there it's written for us. Okay. So we've done the A part. Any questions on the A part or anything else that we covered last time? All right. So let's do the B part now. What's our procedure for solving or simplifying a complicated looking fraction like that? What's the procedure? Oh man, 2 days is a long time ago. Easy.
Part of my problem is they're just side by side. Just a second. Which one are we working on?
Okay. What's our procedure? On any complicated fraction like this, what do we look for first? Common denominators, and that's of all the denominators in both the numerator and the denominator. What is the least common denominator of all those denominators? X squared. Excellent. What do we do with that x squared? We get Sierra to come in. That's what we do. Okay. And it looks like she's so fired up to be here too. Okay. And here is Kayla. All right. Stinson, right? Okay. Anyone else? Since I called wrong. Okay. So we've found the least common denominator of all those denominators at x squared. What do we do with it? Help me. Say again? I heard something, but I couldn't make it out. Multiply numerator and denominator by that x squared. Now, why can we get away with that? Whoa, let me get my pen set up. If I can find. Boy, the system is so bizarre. Okay. So bizarre today. Okay. All right. We're going to multiply the numerator by x squared, and we'll multiply the denominator by x squared. Okay? Now, do you want to distribute first and write that out, or can we do it sort of in our heads? I'll be glad to write it out. You tell me. Write it out or do it in your head? Huh? Write it out. Okay? So, multiplying x squared times 1 gives you x squared. Okay? Minus x squared times 2 over x minus x squared times 15 over x squared. That's the numerator. And the denominator, very similar. X squared times 1 is x squared minus x squared times 11 over x plus x squared times 30 over x squared. Okay, now that's carrying it out in gory detail. Okay, Gibron just came in. Did anyone else come in since I was not looking? Okay, got everybody? Okay. Now, I already multiplied x squared by 1. That was so easy. Let's do this next one, okay, in the numerator. What can simplify there? Anything? Well, x will go into x squared how many times? X times. Because x squared is x times x, and that's an x. One of the x's goes out, right? Yay or nay?
Yeah.
Okay. All right, the next one?
The x
X squareds go out. Both of them are X squared. They go out. Okay? Then the denominator, I already have X squareds for the first term. What happens in the second term? X will go into X squared, X times. And in the second one, the X squareds go out completely. Okay? Now let's write down what our numerator is. X squared is the first term. And what do you have left in the second term? Say it again. I heard the minus. 2x, exactly. You can put them in any order you want to. It's usually we write the coefficient first. Next. Minus 15. Excellent. What's left in the denominator? X squared minus 11x plus 30, is it? Can't read too well. Yeah, I think that's it. Now what do we do? Factor everything in sight. Okay? So, let's hope that numerator will factor. And we'll even hope the denominator will factor. Which you want to tackle first? Second? The top? Okay, is that what you said at the top? Okay, I can't hear well. All right, now how do we start on that one? They both have an x, so x times x. Then where do we look next? Sign of the last term, and that's a negative. What does that tell you about these two signs? One positive, one negative. Got it. Okay? And now what we look for is two numbers that multiply to be 15, but because they're different signs, their difference is 2. 3 and 5. Who wins which sign?
The bigger number goes to the negative.
Okay, so the 5 goes with the negative, and the 3 goes with the positive. Let's just check it and see. X times x is x squared. That's good. X times negative 5 is negative 5x plus 3x is negative 2x. Yes, yes, yes. And then 3 times negative 15 is negative 5 is negative 15. Got it. All right. Now, I was hoping that would help in factoring the bottom because that's a little more complicated looking, isn't it? But it doesn't really help that much because the 3 will go into 30 and 15 will go into 30. But the signs come to your aid here, don't they? Because you know, since this is a positive here, these two signs have to be negative. So we can't use the plus 3. We're going to hope that the minus 5 will work. See, I'm just being lazy. Just plumb lazy with it, okay? So I'm going to hope x minus 5 might be a candidate. Sure looks like it could be, right? And then what would this be? X what? Minus 6. Look at that. I think it works, doesn't it? X times x is x squared. Minus 5x minus 6x is minus 11x plus 30. Yes, yes, yes. Okay? Being lazy pays, doesn't it? Yeah. No. What were you going to say?
This is my question.
Okay.
Are we done?
Not yet. Why not?
Because the x minus 5 can be...
Absolutely. These things are multiplied so they can be divided out. And now we're close to done. Our answer is x plus 3 over x minus 6. Or are we done? Is there anything else we can do?
No.
Why not? Yes, because they're not multiplied. You can't cancel anything. That's why I don't like the word or the term canceling. You don't cancel things, you divide out things. And you can only divide out things that are multiplied. Okay? Because I've seen way too many students start canceling x's and canceling the 3's and canceling things. You can't cancel. You're dividing out things, and you can only divide out things that are multiplied. Let's see how the book did on that. Oh, look at them. They got it right. I'm so proud of them. Okay. So, let's see how we proceed with that. Okay. This is the A part. We've already done that. Well, we'll be through with it. Now, here's the B part. So how did they do? They also found the least common denominator of all the denominators to be x squared, and then they multiplied by x squared over x squared. And for some reason, that just doesn't do it for me. That looks bizarre. I don't even see that these multiply. I like to put the parentheses there and have them on the outside so you see that they distribute. Fine, you know, this typesetter was just being plumb lazy. He didn't know what he was doing. Never mind. Okay. So, when you multiply through, and they don't, well, they do show that. Okay. Here they show 1 multiplied by x squared minus 2 over x by x squared. Since they put it on that side, they're multiplying on that side. Minus 15 over x squared times x squared. 1 times x squared down here. Minus 11 over x times x squared from there. And plus 30 over x squared times x squared from there. Okay, they did it right. That's fine. And now you see, what does this produce? X squared. 1 times anything is itself, so it's x squared. Here, again, the x divides into x squared x times. This is x times x, this is x. One of them goes out, leaving you an x. Here, both of them disappear. Here, that's x squared. One of these goes out, both of those go out. Okay? So that leaves us with x squared minus 2x minus 15, since both of those disappeared. X squared here minus 11x plus 30. Perfect. Just like we got it. And then, of course, what do? Factor, factor, factor. Okay? And they even get Pablo in here. Okay. There you are. Okay. Anyone else come in since I was turned around not looking? Okay. And that simply leaves us with x plus 3 over x minus 6. There's your answer. Cannot be simplified any further, and don't even try it. Okay? Make sense? Any questions? All right. So that's focus on simplifying a complex fraction. There is a check your understanding, A and B parts. I highly recommend that you do those as soon as you can after class, or no later than if you do go to one of those lab sections. Be sure, if you haven't done it by then, do it then. Then they have 4 and only 4 practice problems, and please do those as well. Okay? And that finishes 12.3A, which is 12.3. So, were there any questions before we move on? Forgot to ask. No questions? All right. Then let's move on. Discard. Okay, and that. And let's move on to 12.4A. And one of these days it'll open. PowerPoint has been very slow the last couple of days, so I don't know why. And having these little bitty files that you have to open, several of them during class, it just takes up that much more time. These are some of the reasons I don't really care for the book. The math is fine. I mean, I think the way they present it is fine, but they just don't give very many practice problems. Okay. Let's go to current slide. And we're still in Module 12, so we have another slide just like we've had in how many times before. This time, though, we're doing 12.4 equations containing fractions. Now, what's different from this and what we have been doing? Most of what we've been doing so far have been expressions involving containing fractions. What's the difference in an expression and an equation? What do you almost see there? Equal sign. If it's got an equal sign, it's an equation. Equations, you solve. You come up with an answer. X equals something. Y equals something. T equals something. Expressions, you simplify. You can't solve them. There's no equal sign there. So all you do is get it into a simpler form. So this time we're going to be solving equations, finding what the X is. Okay? Objective 12.4A is to solve equations containing fractions. Okay? That's a nice thing to do with them. Okay. Now, note that to clear denominators, okay, Now, this is something that's even easier about equations than it is simplifying an expression. Simplifying an expression, you have to come up with the least common denominator, right? And then you have to multiply the numerator and denominator, I think, numerator and denominator, then combine. You have all that to do. When you have that little old equal sign there in the equation, once you find that least common denominator, do it a lot like we did in those complicated fractions. Multiply everything by that common denominator. Then you wipe out denominators. You don't have to worry about least common denominator. You don't have to worry about anything else. You just have a simple expression. So actually, this is easier. We multiply each side of the equation by that least common denominator. The result is an equation that contains no fractions. And I know that'll make y'all sad because you love your fractions. Frankly, I'm just happy to live without them. Okay? Well, so in this section, the fractions in the equations contain variables in the denominator. Okay? That's perfectly fine. So, let's see. Don't want to get ahead of myself here. Yeah, let's back off one. And let's do the little example they have there. It's not as if they have too many slides in these things. Why couldn't they have had one here? Here's the illustration they have. Okay, let me get my pen back. Okay. 3x minus 1, this is from your text, divided by 4x, plus 2 divided by 3x, they claim is going to be equal to 7 divided by 6x. Okay? What you reckon the first thing we're going to do? Find the common denominator. That sounds like a capital idea. What would it be? And you look at all denominators on both sides of the equation. Second? 12x. 4 will go into 12, 3 will go into 12, 6 will go into 12, and x will go into x. Okay? That will be our least common denominator. What do we do with it? Multiply everything on both sides of the equation, everything on both sides of the equation, by that least common denominator. Now, I have a feeling I know what they're going to do. They're only going to multiply the entire left-hand side by 12x. I've gone on and distributed it for you. Okay? That works, right? Okay? Is it Jayla? Huh? Johnson. Okay. Kylie. Right? Huh, okay. Now, I thought I already marked Kylie here. Who came in and I thought you said Kylie and you must have said something else. What was your name? Kyla. Okay. Kyla. Got it. Okay. I thought something was fishy there. All right. Got it. All right. Got it. Got you both here now. Kyla and Kylie. Okay. And we got a Kayla and a K. And yeah, y'all are just doing this to throw me off. Okay. Huh?
Call us all by our last names.
Oh, but that sounds so informal. I mean, it's too formal. Okay. Then I have to remember the last name. No. Oh, actually, in my 8 o'clock class on Tuesday, Thursday, I have 3 Higgins. I have 2 Johnsons and multiple, so that wouldn't work for them either. So you're just trying to confuse me, having to do one thing here and another is. All right, good deal. Now, any question about what we're doing there? It's perfectly legal in most states. Multiply everything by the same thing. Okay? Now, what does this first term produce when you multiply 12x by that thing over 4x? Second? Okay. You love to do it the hard way. Okay? You're a hard worker, I can tell. Okay? I'm too lazy for that. Okay? I see that 4 will go into 12 how many times? 3 times. And x will go into x 1 time. So that leaves me just a 3 there. So that's a lot easier to multiply. Right? And I'm lazy. Over here, what do we see? 3 will go into 12 4 times, and x will go into x 1 time. So that's out of the picture. Over here, yeah, 6 will go into 6 once, and the 12 twice. And the x's go out. Good deal. What do we have now in the numerator? First term.
3 times 3 is 9x.
9x. Say again.
3 times 1 is
Negative 3. Perfect. Plus 8 equal 14. Okay, anyone like that better than the first one?
Yep.
I do. Okay, it's a lot simpler. What do we do next? Okay, what do you mean by that? 9x
If you have negative 3 plus 8, then it's going to be a positive 5.
plus 5 is equal to 14. Perfect. Now what? Say again? A little louder. Subtract 5 from both sides. Okay, yeah, get those terms out of the way first. What does that leave us with? 9x equal 9. Oh my, and guess what? Divide by 9, and you get x equal 1. Oh my. Ever anticipate it come out that simple? Okay. Let's check it and see. If you put in an x equal 1, 3 times 1 is 3, minus 1 is 2, divided by 4 times 1 is 4, so that would be 2 over 4, which is 1 half. All right. Here we have a 2, divided by 3 times 1 is 3. Not going to come out as smoothly as I thought. So here we have a 1 half plus 2/3. What does this come out being? 7 divided by 6, right? Okay, 7 divided by 6. That's the question. Is that true? Well, obviously we need to get this in terms of 6. How many 6 is 1 half? 3 6 plus how many 6 is 2/3? 4 6. 3 6 plus 4 6 is 7 6. Yes, it works. Okay? You don't have to check it, but I always like to check it just to make sure I got the right answer. I don't like having wrong answers. I don't like you having wrong answers. So get them right. Okay. Makes it much easier to grade, and I'm lazy. Okay. So, see how that works? Any question on that? The answer is x equal 1. The rest of it was just checking. And they got it in the book, so good for them. All right. Now we move to the focus. And here's the focus on solving an equation containing fractions. 4 over x minus x over 2 is equal to 7 halves. What would you recommend we do first? And what is a common denominator?
2x.
2x. Perfect. What do we do with that 2x?
We have to distribute it so that they all equal 2x. So what we do
Everything is multiplied.
has to be done in the numerator.
All right. Well, no, we don't have to even do that. That's for, that's for expressions we have to do that. Here, all we do is multiply by the 2x. That least common denominator, 2x. Now, what does that give us in that first term? Help me.
You can scratch out your x.
What's that?
You can.
Yeah, divide out the x's, and that gives me an...
You just get a 2.
Not 2. You had a 4 there too, right?
Oh. Oh, wait, you have.
Oh, you're going to the next one. Okay, let's go to the next one.
Oh, okay.
Here we divide out the 2's, okay, and here we divide out the 2's. Okay, we got everything divided out. Now let's go back and multiply. What do we get?
8.
This is 8 minus x squared equal 7x. Ooh, what do we do with that? Help me. What would you recommend we do with that? Make a guess, somebody. Okay. If your maximum exponent by 1, you isolate the variable. But if your maximum exponent is 2 or greater, you get everything on one side, 0 on the other side. Now, which side do you want to move things to? To the left side. Just because you like having things on the left side, don't you? Okay? Here's what I think. I never like having my leading coefficient being negative. I mean, sometimes you have to. I don't like it. So why don't we move this over there? And move this over there, and then we have that being positive, don't we? I like that better. Now, you can do it the other way, but that's going to take probably an extra step or else an extra head scratching. I don't have enough hair left to do. No, okay. Not that funny. Okay. So, what do we do? Second? Okay, subtract 8 from both sides. Is that what you said, or subtract 7x? Which did you say? Okay, sorry about that. We'll subtract 8 from both sides. That loses that one. Then what else do we need to do? Add x squared to both sides. I could write it in front, but I'll write it there. That takes care of this. Now we have a 0 on this side. And what do we have here? Now let's go on and write it in descending order of powers. X squared plus 7x minus 8. All right. Now you want to flip sides now since you like everything on the left? You can if you want to. Or, what would you do next? Factor. Very good. Okay. How does that factor? I'm sorry? X times x, is that what you said? Yeah. Okay, I can't hear well. Okay, now where do we look next? Sign of the last term, what does that tell you?
You do a negative and a positive.
Negative and a positive, okay, I got that. And now what we're looking for are two numbers that multiply to be 8, but because they're different signs, their difference is 7. 8 and 1, and who wins which sign? 8 is the what?
Negative.
8 is negative. Okay, is that what you said? And 1 is positive. Let's check it and see. Yeah, I know. Let's check it and see. All right, he backed into it, so we're going to do it. Okay, x times x is x squared. That checks out fine, right? But then you get a plus x minus 8 minus 7x. And what's wrong with it? The sign. The number's right, but the sign's wrong, so what do? Change signs. Make that the plus and make the other the minus. Okay? I wiped it all out, didn't I? Okay? Now let's check it and see if that works, which is what y'all want to do anyway. X times x is still x squared. Minus x plus 8x is plus 7x minus 8. Yes, that works. And that's equal to 0. So what do we do with that? Set each of them equals 0. X plus 8 equals 0. Or x minus 1 equals 0. One or the other has to be 0, right? To get a product of 0. What does the first one give you? You do what? A little louder, I can't hear. Negative 8. And the second one gives you? X equal 1. Y'all see how to do that. You subtract 8 from both sides here. And over here you add 1 to both sides. Okay. Okay, done. Okay, so that gives you two possible answers. That means we have two things we have to check and make sure they both work. Okay, first we're going to plug a negative 8 in here. What's 4 over negative 8? Anybody? Negative 1/2, right? 4 over 8 is 1/2, but with the minus it's going to be negative 1/2 minus 8 over 2. It's a negative 8 over 2. What's 8 over 2? It's negative 4, but you have a minus sign in front, so then I put a positive 4. So you have a negative 1/2 plus 4. So that's 3.5. And what's 7/2? 3.5. So yes, that checked. All right, we feel good about that one. Everybody see it? You don't have to check it, but it just makes you feel warm and fuzzy inside if you got it right, right? Okay, good. Now let's do x equal 1. This should be easy. 4 over 1 is 4, minus 1 over 2 is 1/2. 4 minus 1/2 is 3.5. 3.5 is 7/2. Yes. Got it? See how both of them work? Good deal. Okay. Again, you don't have to check, but why not? Just make sure you got it right. I want you to get it right. Okay? Makes my job easier. Okay. And that's your goal in life, is to make my job easy, right? So get them right. All right. You want to see how they did it? You okay? Want to see it? Ready? Okay. All right. First thing they did was write it down again. That's a good move. Okay. Okay. But they do note that the least common denominator of all the fractions is 2x, just like y'all determined. And then they multiplied 2x by the left-hand side and by the right-hand side. This time they did it on the left, which I like better. Okay. And let's see if they're going to do another step here. Yes, they do 2x over 1, which is clever, times 4 over x, minus 2x over 1, distributing it by x over 2, and then 2x over 1 times 7/2. Okay? Here, and they're going to skip this step, I'm pretty sure. The x's will go out, and that leaves you 2 times 4 is 8, minus, and here the 2's go out, and that'll be an x squared, and here the 2's go out, and that'll be a 7x. Let's see if that's what they do. Yes, that's what they did. 8 minus x squared equals 7x. They didn't show you how they got that, but we did that, right? Makes sense, right? Okay. Now let's see what they do. Oh, they notice this is a quadratic equation. Yes, maximum exponents too. And what do they do next? They move things to that side too, because they also like to have that leading term positive if possible. So that's what we did there. And then let's see. They call that standard form, which it is. 0 on one side, everything else on the other side. Then they factored just like you did and got the same result except for Seth. And then they solved that equation. X plus 8 is 0, x minus 1 is 0. That yield x equal -8 or x equal 1. Just like you did. And then they said they check as a solution. They didn't show that they did, but they want you to. I want you to, but it's up to you. Those are the answers. That's what I'm looking for. Always a good idea to make sure they're right. Okay? Any questions? So that was focus on solving an equation. Okay? So the solutions are -8 and 1. Okay? I thought they already determined that. Okay. Before we get there, there is a Check Your Understanding 1 at the top of page 17 in Module 12. Okay? Please do that as soon as you can after class, whenever you can get to, no later than your practice session if you have one of those. Otherwise, as soon as you can. All right. Now, moving on, they say occasionally a value of a variable in a fractional equation makes one of the denominators 0. So, anything wrong with that? You can't ever divide by 0. So yeah, there's something really big wrong with that. If that's the case, then that value of the variable is not a solution to the equation. You can't have a solution that makes no sense. Okay? I can always hear someone say, none of this makes sense. But y'all didn't say that, did you? That was another class. Okay. All right. So let's see. There's the focus, but before we get to the focus, they do an example. So let's do the example. 2x over x minus 2 is equal to 1. See, there's that equal sign. We like those, don't we? Plus 4 over x minus 2. Okay? Now, a couple of things different here. Number one, these are binomials in the denominator, not monomials. But guess what? We still do the same thing. What's the first thing we look for? LCD. And what would it be in this case? X minus 2. And what do we do with that x minus 2? Multiply everything on both sides by x minus 2. Even this 1 over here by x minus 2. Even this fraction over here by x minus 2. Multiply everything on both sides by x minus 2. What happens to the left-hand side here? Second, 2x, because x minus 2 divide out by, to be 1, right? So that leaves you just a 2x. Equal, what happens when you multiply x minus 2 times 1? You get x minus 2. Excellent, okay? And then plus 4, because here the denominator goes out again. Good, now what do we do? Combine like terms. So you get 2x is equal to x plus, second, plus 2. Is that what you said? Okay, good. Now what do we do? A little out. Okay. If this was a quadratic or higher, that's exactly what you do. But this is maximum exponent is 1. So what do we do now? Get all your variables on one side and everything without a variable on the other side. We isolate the variable if maximum exponent is 1. So what would you suggest we do to do that? Do what? Subtract x from both sides. That sounds like a winner to me. Okay? And what does that give us? Okay, this gives us 2x minus x is equal to 2. Looks like a solution, right? And since we don't like checking, we're not going to check it, are we? No. Okay? And what happens if we don't? You don't know if it's right. Well, let's check it. Let's plug in x equal 2 in our original equation. 2x, that would be 2 times 2 is 4. Fine. Over 0. What did you say about that? Never divide by 0. This one has no solution. X equal 2 cannot be a solution because that would leave you not making sense. So now you see another reason to check your answers. It may, so no solution. That does not work. It makes the denominator 0. So basically what they're saying is that's an impossible situation. Okay? So, no solution. All right. That equation has no solutions. All right. Now I think we're ready for the focus problem. Are y'all ready for it? Good deal. Whether you are or not, here we go. So here we have another equation. 3x over x minus 4 is equal to 5 plus 12 over x minus 4. What do we do first? Anybody? Find the least common denominator. What would that be? X minus 4. What do we do with that x minus 4? Multiply it by everything on both sides. So it would be x minus 4 here. 5 times x minus 4. And that thing times x minus 4. Okay, what does the left-hand side produce? 3x. Because x minus 4 is divide away. Okay, multiply to be 1. What do you get there? 5x minus what? 20. Perfect. Good distribution. Next. Plus 12. Okay, so you get 3x is equal to 5x minus 8. Okay, now what? Okay, and how do you do that? Subtract 5x from both sides. What does that give you? Negative 2x equal, those go away, minus 8. Divide by negative 2. And that gives you x equal positive 4. Done. Move to the next, right? Huh? No, why not? You need to check it. What happens when you check it? You wind up having 0 in the denominator again. Nope. Better not stop there. No solution. Okay, because x equal 4 will make that problem meaningless. You can never divide by 0. So don't even try it. Okay? Now, don't think that every one of them is going to turn out this way. They've just shown you a couple of examples that do, but they won't all. Okay? There's a check your understanding here, so please do that. Bottom of the page 17 in Module 12. And then there are 5 practice problems. Please do all of those whenever you can. When you get to your lab period, or if you don't go to the lab period, do them sometime. Any questions? Oh, let's see how they did it. Okay? All right, they started by writing the problem over again. That was a useful step. Okay? And then they and they did find out the least common denominator was x minus 4. So then they multiplied the x minus 4 by both sides of the equation. They do it in 2 steps, where I just do it in 1. This times that, just like we did. They do this times the whole thing and then distribute. That's all I've done is distribute all at once. Okay? So that gives us 3x on the left-hand side times x minus 4 times 5 will be the first term. And the second term, the x minus 4's go out, and it's just a plus 12. To me, that's certainly fine. It's correct, but it's not as obvious to me. But you decide what you want to do. Okay, so the 3x will equal 5x minus 20 plus 12. That would be the next step. Okay, then they subtract, they combine like terms, and do the minus 8. 3x minus 5x is equal to 5x minus 8. Subtract the 5x from both sides. Negative 2x equals negative 8. Divide by negative 2, x equals 4. But it does not check as a solution when you go to do it, because you wind up with a 0 in the denominator. No solutions to this. That equation has no solutions. Period. Okay? Now, on the next test, don't even try anything. Well, I guess you can try it if you want to. You can't figure out something. It's like, no solution. That's like you did before. No fact, not factorable. That time you were actually right on some of those. Okay. But anyway, that's the last thing in 12.4A. So let's move on. Were there any questions there before I move on? Okay. Let's go to 12.4B. I like having to do this every time. Okay. Here's 12.4B. And one of these days it'll come up. There it is. Okay. We'll start the slideshow from the current slide. And there's our favorite PowerPoint again, Module 12, Rational Expressions. This time 12.4, same as last time, equations containing fractions. And this time it'll be 12.4B will be to solve problems involving similar triangles. All right, we like solving problems, don't we? That's why you leave so many of them blank on your test. Never mind. Okay. Don't do it. They're fun and easy. Well, they're doable. Okay. Now, similar objects have the same shape, but not necessarily the same size. Okay? I don't know that this eraser is similar to the board, but see, it's long this way and short this way. The board is long that way and short this way. If those were by the same proportion, then these would be similar shapes. but only if they're by the same proportion. Okay? I'll draw you another possibility. There's not much room on here, but let's say we have, let me get my pen back. Okay? That is a triangle, or that is a triangle, or that is a triangle. Okay? Now, this triangle, this angle's the same. These are all 90s here, so this angle has to be the same. So this triangle is similar to that triangle, is similar to that triangle. Same shape, same angles, but different sizes. That's what we mean similar objects. Those are all similar triangles. That might have been a similar rectangle, the eraser to the board. I don't know that it is. I doubt it is. Okay? They have the same shape, but not necessarily the same size. A tennis ball is similar to a basketball. They're both spheres, right? Okay? Also similar to a ping pong ball or a golf ball. Okay? Or the earth. Okay? Okay? They're all similar. The model ship is similar to the actual ship. Okay? If it's proportioned right. And most of the time they do that. I actually saw sort of a YouTube video of a guy who was in the Navy. I think he flew, okay. He flew 8-4s, I believe it was. And he built his son an exact replica of an 8-4, but scaled down by 1/3. And he made out of plywood and stuff like this. It didn't actually have the engine in it, but he also had all the pedals and the things, so the ailerons and the rudder and everything else moved same proportion that the actual A6. And then he actually had he was in the Navy, and he wangled around and had someone paint it exact colors of the A4. The blue and the blue, okay? So it was pretty amazing. Those were similar objects, okay? The relationship between the sizes of the corresponding parts can be written as a ratio. And guess what a ratio is? Comparison in the division sense, a fraction, okay? And each ratio will be the same. If the rudder on the model ship is 1/100th the size of the rudder on the actual ship, then the model wheelhouse should be 1/100th of the size of the actual wheelhouse. The width of the model would be 1/100th the width of the actual ship, okay? Everything should be on that scale of 1/100, okay? Guy did his by 1/3, this one by 1/100th. And ships you have to do a little bit smaller scale, okay? Now, here are a couple of triangles here. And by the way, they name triangles by putting capital letters on the vertices of the triangles. So this is A, B, C. You could have done it in any order you wanted to. They just chose to do that. But A, B, C, they say, is similar to D, E, F. Now, once you name this one, you have to do those in the same order. Okay, and here's why. Side AB, which they told us was 4, and that DE was 8, so then everything had better be by that ratio. And sure enough, this is 3:6, and that's 2:4. But all of them are exactly double. Okay, which means the perpendicular here happens to be 3, here, then would be exactly half, so that would be 1.5. Everything is by that same ratio, okay? That's what they say in all this blah, 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 okay? And you see, they just said it all. Same thing I said, pointing to it, they said down here. Make sense? That's what we mean, similar triangles. Every ratio has to be the same if they're similar corresponding sides or measurements, okay? Because the ratios of these corresponding parts are equal. And by the way, go back here, this is true for geometric figures. Just because the sides are by that ratio, the angles are not. This angle is the same as that angle, this angle is the same as that angle, and this angle is the same as that angle. Why is that? All triangles add to 180 degrees. So guess what? You can't double each of those angles. That would add to 360, and that would be a triangle then. So the sides are by those ratios, not the angles. Just remember that. Angles would be the same. Okay. You're not worried about angles. Okay. Because the ratios of the corresponding parts are equal, the three proportions can be formed using the sides of the triangles. In other words, AB is the DE, those are the base sides, as either or the other. AC is the DF, or BC is the EF. Okay? Or AC is the DF, as BC is the EF. All those ratios are the same. Now, when you have two ratios being equal, that's called a proportion, by the way. Three proportions can also be formed using the sides and heights of the triangle. Okay? So AB is the DE, that's the bases of both of those, as CH is to FK, those are the heights. But AC is the TF and CH, yeah. All those ratios are the same. Okay? The corresponding angles in similar triangles, though, are equal. Okay? So angle A has to equal angle B. Angle B equals angle E, and angle C equals angle F. That's what I said, too. I didn't know they were going to say it again. Also true that if the three angles of one triangle are equal, respectively, to the three angles of another, those two triangles have to be similar. Their sides will be of equal ratio, no matter what the lengths are. Okay? So this is just like the one I drew earlier. Angle C is exactly the same. Here's angle triangle ABC. There's your base. Okay? Angle X and angle Y, or whatever they are. The angle C would be 180 minus that. Well, if you draw a line parallel to this base up here, anywhere up here, then you're going to get a similar triangle. Why? Because if you have parallel lines here, one line cutting them, these two angles have to be equal, and these two have to be equal. Now, if these lines weren't parallel, all bets are off. Those are not similar triangles. They would have to be parallel lines here. If they are, then these two are equal, those two are equal. That's the same on both of them, so those would be similar triangles. We may not know what the ratio of AB to DE is, but it's the same as the ratio of AC to DC, and BC to EC. All of those have to be the same ratio. Okay? So anytime you have a line segment drawn parallel to the base of one triangle, those angles have to be equal, because parallel lines cut by a transect will have equal corresponding angles. Okay. I think that's saying everything I just said, maybe in slightly different terms. Okay, everybody see that? Okay. Now, I've said this, the sum of any three angles of a triangle always, always, always is 180 degrees. Two angles of one triangle are equal to two angles of another triangle. Third angle has to be equal. Thus, we can say if two angles of one triangle are equal to two angles of another triangle, the two triangles are similar. Guaranteed. Okay? Now, let's see if they do something else first. This is the figure at the bottom of page 19. They have something at the top of 19, so let's do that first. Looks like the best place to do it. All right. All right. Triangles ABC and DEF are similar triangles. Now I'm going to try to draw them. Obviously, my drawings are not going to be quite as pretty as the ones in the book. Almost, but not quite. Let's just say this is A, B, C. Okay? That's not quite the same as the book. And then this would be D, E, and F. Okay, now I admit they're probably not exactly similar, but let's just imagine they are. Okay? So ABC and DEF, let's just say they are similar triangles. It says find the area of triangle ABC. Well, they tell us here that this is 5 inches down here. AB is 5 inches. Okay? They also draw in a perpendicular here that they call H here. That's all they do. Okay? Here is D, and here they say DE is 12 inches. Okay? And they say that this perpendicular here is 3 inches. And they name that point G down here. G, I like that. Okay. Now, they ask for the area of the little triangle, ABC. With what they've given us here, we can't find it. Okay. But they have told us this and those are similar triangles. And they did give us that height. Okay, what do we need to know the area of that triangle? What is the formula area of a triangle? Anyone know that? Area of a triangle is, anyone know it? You probably do. Second? If you've got your books, let me see if it's in your book. It should be, but I can't swear. This book is a little on the shady side. Sketchy side, you might say. Let's see. I'm beginning to think they may not have it in here. Glad they put all these. Well, I'm not going to waste any more class time looking for it. But you should know the area of a triangle. Anyone know it? 1/2 the base times the height. All right, you knew that, didn't you? Okay. Now you can choose anything to be the base, any one of the 3 sides to be the base, but then the height is the perpendicular from that side to its opposite vertex. Okay. So this one, this is the base. There's the height. We just don't know the height here, do we? Okay? But over here in the similar triangle, we know its base and we know its height. So what else do we know then? We know the ratio of the base to the height, or the height to the base. What is that ratio? 12 to 3, is that what you said? 12 inches to 3 inches. Okay? But that ratio, because they're the same units, the inches go out. And what's that ratio? 4 to 1, right? Or just 4. So therefore, the height, you can take this now and say the base is equal to 4 times the height, right? If you multiply both sides of this by h, then you get base equal 4 times the height. Okay? Which means the height is equal to 1/4 of the base, right? Got that? Divide by both sides by 4. Now we need to know what the height of this one is. Can you make a guess? It's a similar triangle, so the ratios are the same. Yes, it's be 5 over 4. The base divided by 4, which is 1.25, if you like using decimals. Okay? So now that you know the height, you can do the area. 1/2 the base, which is 5 inches, times the height, which is 5/4 of an inch. Sorry, I didn't write that. And let me clean that up just a little bit. Okay? Now, sorry this is getting a little crowded. The numerator is 25, and the denominator is 8. So 25/8, and you multiply the units together, and that gives you square inches. Now, if you want to write that as a decimal number, what would that, well, you don't have to. You could write that as a mixed number. That would be 3 1/8 square inches. or you could write it as a decimal number. It's 3.125 square inches. Okay? That's what I got, and look at what they got. 3.125 square inches. Now, they may have done it a little bit differently, but you're using the ratios however you want to use them. That will work. Make sense? Any questions on that? Got it? Okay. Now, that was their little illustration. Then they did the this one here. I got it out of order. And then they're ready for this one. Okay? Now, they don't call this a focus. Oh, that's not the same, is it? Okay, how are we doing? Are we going to have time to do this one? I'm guessing not. Okay? So we will start next time with this. We're not quite ready for a focus yet, but we will do this one at the bottom of the page here. Now, let's take a look and see where we are and what's going on here. All right? We'll finish 12.4B. We've got 12.5 to do and 12.6 to do. Okay? All right. It looks like to me that probably, I'm guessing we probably won't finish 12 next time, which will be Monday. But we probably will finish by Wednesday. So the plan for the next test to be the following Monday. Now, if we do finish all that on Wednesday, then we'll be ready. On Monday, we'll be ready for the test on Wednesday. All right. Yes, sir. Oh, by the way, anyone that did not get a quiz last time, please get a quiz before you go. Okay? You've already put one in. Okay, what you say? I'm sorry.
Can I get a quiz?
Yes.
Please. How bad was my test? How bad was my test?
Oh, it wasn't bad, I don't think. Good deal. He's coming in already. Quiz? What's that? Oh, okay. All right. Y'all are looking for test 2, right? Okay. Five. Kirsten. Ivy. Okay. Here's yours. I need it back, so don't run off with it. Becca, Gary, Taylor. Did you need to see yours too?
I've already seen mine.
Got it?
I'm sure he showed it to me.
Yes, sir. Huh?
You
Oh.
have my test again? I can't remember.
Okay, you want yours pretty close to it.
Did you give it to me?
Okay.
I forgot how to do those.
What's that?
I couldn't remember how to do those.
Okay. You remember now?
No, I still remember.
Okay. I was going to let you work on them if you wanted to.
I tried to figure it out. I just couldn't get like the wording.
Okay. That's really the key, is to translate the words into algebra statements. And we'll be doing some of those coming up.
As long as we
What's that?
As long as if we hit that again, I'll be good.
Okay. Yeah. Okay. Good sport.
I'll talk about that at the end.
Okay.
Thank you, sir.
Uh-huh.
I have my
You have your paper. Oh, okay. That's a funny looking paper. Okay.
digital paper.
I see. Okay.
I don't have a printer at home.
Oh, okay.